Okay, this is AVL Tree Example 2 video. So this is Example 2. There's a previous video, Example 1, where I go through the basics. You should watch that first if you haven't already. So here's the rules from that once again, and here's a document that's posted on my website that is the output from a program that you can use to check your work. Also, once again, there are lots of AVL tree animations on the web, and you're welcome to look at those to check your work to make sure it's right. Yeah, so I'm going to do this sequence right here, 7, 8, 9, 2, 1, 3, 4, 5, 6, and I just have this here to check my work. I'd like you to, for your homework, to do something similar to what I'm going to do on this little piece of paper right here. So let's get started. So the sequence is 7, 8, 9, 2, 1, 3, 4, 5, 6. So insert is 7. We find the new node, insert position, which is the root is trivial for the first node. So we're done. Okay, then the 8 is going to go here. Has a balance factor of 0 because it's a new node. Then you find the pivot, right? There's the pivot. The pivot is the first node up from the new node with a non-zero balance factor, or the root. In this case, it's the root. Find the pivot first, then update the balance factors. Okay, after you find the pivot, update the balance factors between the new node and the pivot. So this one's going to be longest branch on the left is 0, longest branch on the right is 1. So it's 0 minus 1 is going to be minus 1. So we can't fix that. So that's as good as it gets. So redraw 7, 8. It's time to insert a 9. So the 9 goes here. It's a new node, has a balance factor 0. The pivot is the first node up from the new node with a non-zero balance factor. In this case, it also happens to be the root. Okay, find that first, then update the balance factors. And this one becomes a minus 2. We can fix that. So we're going to do a rotation. Which one? Well, we go down, we follow down the path from the pivot, and the first 2 turns down from the pivot are rights. So we're going to do a right-right rotation. Now, right-right rotation is just like a left-left rotation. It looked at in a mirror. So you mirror everything. So this is going to be A, this is going to be B, subtree 1, subtree 2, subtree 3. So the new orientation is B here and A here. Those are going to have balance factors of 0 always. For left, left, and right, right. After the rotation, the lettered nodes have balance factors of 0. The subtree 1 is there, subtree 2 is there, subtree 3 is here. A is 7, B is 8, and that's it. So we redraw to keep from going crazy. So there it is. All right, now it's time to insert a 2. So start here, we go that way, we go that way. So 2 goes here. The pivot will be this. We're just going up, looking for a non-zero balance factor. In this case, we run into the root, so it's the root. Find that, then update this. It's going to be a balance factor of 1. There's going to be a balance factor of 1. Can't fix 1s, so we redraw. So 8 goes here, 7 goes here, 9 goes here, 2 goes here. It's time to insert a 1. So the 1, right, start here, here, here. 1's going to go here. It has a balance factor of 0. The pivot's going to be here because it has a non-zero balance factor. Just going up from the new node. Okay, find the pivot, then update the balance factors. This is going to be 1, this is going to be 2. We can fix that. Okay, because it's heavier. This node here, node 7, is heavier on the left by 2 than on the right. So it's going to be a left-left rotation. This will be node A, this will be node B. We're going to do a left-left rotation. So these two guys stay the same. B goes over here, A goes over here. This is subtree 1, subtree 2, subtree 3. Subtree 1 is 1. Subtree 2 and subtree 3 are null. A is 7, B is 2, and A and B have balance factors of 0 always. Okay, doing a redraw of this guy, it's going to be that. Just to check the balance factors real quick. This guy's balanced, this guy's balanced, this guy balanced, this guy heavier over here on the right by 1 than the left. The right, I mix up my right and left a lot, but the left is heavier than the right because it's longer on the left by, the longest branch on the left is 2 and the longest branch on the right is 1. So 2 minus 1 is 1. Okay, then you insert, what did we just do? We did 1. So now it's time for 3. So start here, 3 smaller, 3 bigger, 3 smaller. 3 goes here. It has a balance factor 0. The pivot, you follow up here looking at these balance factors and you stop there because it has a balance factor of 1. Okay, then you update the balance factor. So this is going to be 1. This is going to be minus 1 because it's 1 long this side minus 2 long. Or a length of 1 minus a length of 2 is going to be 1 minus 2, which is minus 1. This one, the longest branch has a length of 3. The longest branch on this side has a length of 1. So this guy becomes 3 minus 1. It becomes 2. Has a balance factor of 2, which means that it's heavier on the left. It's 2. See, it's this much longer. There's 2 more guys longer than this side. So that means we have to do a rotation. Which one do we do? Well, we look at the first turn down from the pivot. And the first turn is a left, then it's a right, right? Starting from the pivot, first we went left, then we went right. So we're going to do a left-right rotation. So you look over here, and what it says is this A, B, and C orientation becomes this thing, this CBA orientation. So this is C, this is B, this is A, and A is this is A over here, this is B, this is C. So A is 8, B is 2, and C is 7. And this has a balance factor 0 always. This is subtree 1. This is subtree 2. This is subtree 3. This is subtree 4. To look over here, you see 4 is hanging off of A, and 2 and 3 are hanging off of C. Tree 1 is hanging off of B. Okay, so then you hook up the subtrees like that. So this is tree 1, which is a 1. This is tree 2, which is a 3. This is tree 3, which is null, and this is tree 4, which is a 9. Then, so after the rotation, C will always have a balance factor of 0, but B and A, there's some rules here that say what the balance factors are, and if we were implementing that, we would use those rules. But for here, we're just going to look. So this guy, this guy's balanced, right? Because it has these 2 guys on there. And this guy here is 0 minus 1 is minus 1, which is this case right here. Okay, so redrawing this, redrawing this guy, it's going to be 7 to 1, 3, 9. And just a quick check of the balance factors. This is balanced, this is balanced, this is balanced. This 7 is balanced. 8 is heavier on the right by 1. 9 is balanced. All right, it's time to insert another value. And last time we did 3. So now it's time to insert 4. Just going by this sequence that we have over here. So I'm going to insert a 4. So we start here. 4 is less, 4 is bigger, 4 is bigger. So the 4 goes here. It has a balance factor of 0 because it's a new node. We find the pivot by going up, looking for a non-zero balance factor or the root. So it's the root. Then we update the balance factors. So we update the balance factors between the new node and the pivot. So this one is -1. This one is 1 minus 2, which is -1. This one is 1, 2, 3 minus 2, which is 1. So no rotation required. So we'll just redraw and you could do a quick check of the balance factors to see that it's no node is off by more than plus or minus 1, which is the best we can do. Okay, now it's time to insert a 5. That's the next number in our sequence. So we start here. 5 is smaller than 7, 5 is bigger than 2, 5 is bigger than 3, 5 is bigger than 4. 5 goes here, has a balance factor of 0. The pivot's going to be this guy because this has a non-zero balance factor. Then we update them. So this becomes -1. This becomes -2. Because you see it's long on the right. It's -2. 2 means, plus or minus 2 means we need to rotate. So the first 2 turns down from the pivot are right and right. So we're going to do a right rotation. Okay, a right rotation once again is just like the left rotation. If you imagine both of these in a mirror. So if this is going to be A, this is going to be B. Tree 1, tree 2, tree 3. Most of the tree stays the same. Well, some of the tree stays the same. That stays the same. Then here, this is where we're doing these operations here. B, A. Because here it's A, B, the orientation. A on top, B to the right. So B will be on top and A will be to the left. These will both have 0 balance factors. The subtrees will be here, here, and here. Tree 3 being the only non-null tree. B was 4 and A was 3. So I'm gonna redraw because, so just redrawing this guy. So 7, 2, 8, 9, 1, 4, 3, 5. That's okay, right? Yeah, so now we're going to insert a 6. Start here. 6 is smaller, 6 is bigger, 6 is bigger, 6 goes here. The pivot's going to be this guy, because the pivot is the first node up from the new node with a non-zero balance factor, so it's this guy. Okay, you find that first, then you update the balance factors just between the new node and the pivot. It's magic like that. These trees can be huge, and you're only updating a little bit of stuff on the path you just took, so it's very efficient. So this is going to be 0 minus 1 is minus 1. This is going to be 1 minus 2, which is 1. No, minus 1. This guy is going to be length of 1 minus the length of 3. So this guy's going to be 1 minus 3, which is minus 2. Minus 2 means we need a rotation because we're out of balance by 2. It's longer on the right. This node is longer on the right than that node. Okay. Which rotation do we do? To determine that, we look down from the pivot node on the first 2 turns, which are right and right. That means we're going to do a right-right rotation, which is the mirror of this guy again. So this is A, this is B. So much of the tree stays the same here. This stuff is the same. This thing, this becomes B, and this becomes A. Because here it's A on top, B over here. So here it's going to be B on top, A on the other side. And the subtrees are this one, tree 1, this one, tree 2. This whole thing here is a subtree. This is tree 3, right? Because the subtrees are hanging off of A and B. There's 2 off of B and 1 off of A. And same thing here, it's just A and B are mirrored. There's 1 off of A, 1 tree off of A, and 2 trees hanging off of B. So this will be tree 1, this will be tree 2, this will be tree 3. So tree 1 is just this 1. Tree 2 has this 3 in it. Tree 3 is a 5 and a 6. And B is 4 and A is 2, and they have balance vectors of 0 after a right. And I think that's it. What happened to the balance factor on 7? I lost it. I think it's still 1. I think it was a 1 way back, and I dropped it along the way. It's still 1, right? Yeah. So we'll redraw just to make this pretty. So 7. I think we're done. Yeah, 7, 4, 8, 9, 2, 5, 6, 1, and 3. And just to check of the balance factors, this guy, the longest branch is length of 3 on the left, and minus the longest branch on the right with a length of 2. So 3 minus 2 is 1. So it's cool. This one, longest branch is 2, longest branch is 2. So 2 minus 2 is 0. This one is heavy on that side by minus 1. 0, 0, 0, 0. This one's heavy on that side by minus 1. It's all cool. So it's cool. All right. That's it. There's a third tree that you could use to check if you need some more. There's plenty of materials on the interwebs. You guys just do something that looks like this. You make it prettier than this, as I always say. Okay, that's AVL trees. The next thing after this is B trees, which is another academic thing. You know, the point being that there's all kinds of trees, and you know, we sort of look at several just to kind of get familiar with a couple of points along that, what is really a continuum of things you could do. And B tree is a good thing because it lets us talk about why you would need such a thing. And really, it kind of, most of the time, it comes down to architecture when you're making really big systems and you're dealing with memory and different configurations with different characteristics. And yeah, these are all just academic programs, and in real life, they're gonna ask you to do something that's never been done before, and you'll draw from all of these little things that you've looked at along the way. Okay, thanks.